and the Simulink start page will pop up. Now here you can see this open button. When you click here, a window will pop up and you can open your previously saved files, right? Your previously saved models, you can open it through this section. This section shows the recent files. The recent files that you have worked with that can be seen over here. Over here, you can go for the recent projects. Whatever project you are working on, you can save those projects in this section and you can open it from here. Now we'll come to these two tabs. This tab provides us pre-designed templates which you can directly use to create your project. Over here, you can see there are different types of Simulink models, communication system, DSP system, embedded system, powertrain blocks, and so on. So there are lots of pre-decided templates which is available for new users. So we'll just quickly close it for some time so you can have a full look. You can even create your own template which you want to frequently use, right? We are not going to discuss how to create your own template. For that, we'll make a separate video if you want to learn how to make your own template which you really want to use frequently. So you can write that thing in comments and I'll explain how to make your own template. Now we are going to explore another tab that is for examples. Earlier, we have discussed that Simulink can be used for multi-domain applications. Over here, you can see the examples of all multi-domain applications where Simulink can be used. SimCaps electronics, SimCaps power systems, Simulink 3D animation. You can see there are ready-made examples of 3D animation. Let me click it and quickly show it to you how does it works. When we run this thing, simulation will pop up. And over here, you can see how the simulation is working. So here you can see speed, longitudinal acceleration and lateral acceleration. So let's close it. So there are varieties of example available and you can select your domain and starts working with Simulink. If you are a beginner, then this example will be really very much helpful for you to learn Simulink. Through this search box, you can even find the examples that you are looking for. Let us try something. Let us open this. So this is the model of three-phase asynchronous wind turbine generator. Now let us run this program. To run this program, you need to press this green run button. You run it. It will compile. And simulation is done. Through this scope, you can observe the real power and reactive power quantity. Now we'll close this thing and we are going to open a new blank model. So for that you can click here and you can go for blank model. So we'll close it. We don't want to save this and we'll maximize it. Now this is the menu bar. Each of the menu bar has varieties of settings within it. We are not going to discuss all of this in detail, right? But while you are practicing Simulink, if you are having any query on any of the block and any of the parameter, then you can directly ask me in comment section below, or you can join my Telegram group where we are discussing all the issues coming in Matlab and try to sort out the issues of the students, right? So you can even join me in my Telegram group. You can join me on my Instagram, Facebook, whatever platform is appropriate for you. You can join me there and you can ask your questions. If many students are asking similar questions, then I'll probably make video on that topic. So you're open to ask me. If I know the answer, I'll definitely share it with you. So we'll start with this second bar. This button will pop up this menu. So from here you can open the blank model, chart, library and project. And there is a shortcut for that. Ctrl+N will pop up a new blank model file. Through here you can open previously saved your models. The next is to save your current model. We have yet not saved this model, so when we click this thing, it will ask us to save the model. So let me save it. And let me save it in a wrong manner. I'll give it name my space simulation and I'm going to save it in my folder, and this error will pop up. My simulation is not a valid model name because it is not a valid Matlab function name. So the problem here is I have intentionally provided space between two letters. So remember that you cannot provide space between two letters. So my underscore simulation, and now save. So the name is done. Now this button is for library browser. When you click it, you can observe graphical blocks of multi-domain. The list of all domain is provided over here. This is Simulink. In this Simulink, you will find there are varieties of headings like commonly used blocks, continuous blocks, dashboard, discontinuous, discrete, logical, lookup table. Varieties of block sets are available in Simulink. Let us explore these sources. This is the set of sources. You can find a step source, sine wave source, ramp, pulse generator, constant, clock, so many things you can find it here. Let us take any of this. This is the sine wave block. We'll just right click it and we'll add this block to my simulation. You will click it, then it will directly add this thing to the block. This sine block is here. Let me show you another way how you can import any block to this Simulink model. Just double click and start writing the name of the block. So we want to import another sine wave, so we'll write it sine wave and click. So another sine wave has been imported. When you hover your arrow onto the sine wave block, it will ask for the amplitude. It is the amplitude of your sine wave. By default, it is 1. If you want to change, you can change it to 2, 3 or whatever number you want to give. Let's make it 3. So the amplitude of this sine wave is 3 and this sine wave is by default 1. For example, if you have missed to enter the amplitude, you can anytime double click this block and set the amplitude. In this block, you can set varieties of quantity. Right now, we'll be focusing only on amplitude. Amplitude is 1. Later on, we'll see how to change this quantity as per our need. Now, I'll quickly prepare a simple model and then we'll explore the rest of the things. From here, you can directly search for any block. For example, sum. So when you search here, it will show the variety of result which has the word sum. Let us tag this block. So this block is here. Now we want to observe the result of these two. Now we'll add these two together and then we'll see the result. To see the result, we are going to use the scope. Library. In sync, you can see varieties of output displaying devices. So from this, we are going to select this scope. So this is the scope. When you run, you can see the result in output. Now this button is for model configuration parameters. You can configure different parameters of the current model. You can set the solver, simulation time, starting time, stop time, the types of solver you want to use. There are varieties of solvers. These are different solvers which are used for different applications. We will make a separate video to understand which solver is best suitable for which type of simulation. This is the variable step or fixed step type of simulation you want to do. If you want to import the data, you can directly import data into this simulation file. You can even export the data from the simulation file. You can do varieties of things from this configuration parameters. The next is Model Explorer. It will give you the idea of different block set in the model. And this is the tab through which you can run the simulation. This is the time of the simulation. You can set it to any of your required time, 5 seconds, 2 seconds, 10 seconds, whatever you want to adjust. And the rest of the things we are going to explore in our upcoming videos, so stay connected to this channel. Now on this left hand side, you can see there are varieties of buttons. Through this button, you can zoom in this model. This is the fit view. If you click it, it will adjust it to fit view. Through scroll button, you can zoom in and zoom out. It is zoomed out a lot. Just click this and it will adjust to a fit to screen view. Then from here, you can add annotations. You can click here and write whatever you want to write over here. Click here, you can place here. You can write signal or whatever you want to write. This is the block where you can place area and write whatever notes you want to write. You right click it, you can adjust the font style. There are varieties of font styles are available. You can adjust the size of the font, italic, bold, and different varieties of fonts you can choose. By right clicking, you can even select the varieties of color you want to set. If you want to set any particular color, you can set from here. You can insert image in this simulation. You click it, click over here, double click it, and it will ask to insert image. Click, select any of the image.
I'll double click it, and here you can see these are the different blocks. Again, I'll enter a few of the things over here. For example, sine wave, and again summing block, right? Together, this will create another subsystem. So here, this is our main simulation. There is one subsystem within it, another subsystem within it. Now, if you are having a large system and you want to work in this subsystem and then you want to go again back to that simulation, then back and forth it will take too much of time, right? And it will become a little bit tedious when you want to go back and forth very frequently. So for that, this is the solution. Double click this subsystem, again click it, it will save this view as a view marker. Again go into the system and it will set this thing as a view marker. Click it and it will save a view marker. So we have set 3 view markers. Only going back and forth is not the purpose of this view markers, but to set you in that particular predefined view. That is the fundamental use of this view marker. For example, we are in this system, we'll go to view marker.